Oh, hello everybody. I'm still home, not feeling well, but I'll get there. I'm going to. So here's our dilemma, and we can do this because we're good students, we're smart. The copy machine's broken, so I do not have a copy of this. So we're going to do this old school. So hopefully you have an extra sheet of paper out in front of you or your notebook, and I'll just take my time, and if you want to take a picture of my notes when we get done, just ask Mr. Piper, and he'd be happy to do that. Okay, so have him pause the video anytime you need him to pause it. Let's get started. Here's the review. Okay, so number one, I'm going to start out. 3 times the square root of 48. Well, what I know is that 48 has a perfect square. Square root of 16 times the square root of 3. I like that because I know what the square root of 16 is. It's plain old 4, right? And then I can finish this. 4 times 3 makes 12. I don't really want to take the square root of 3 because it's an ugly decimal number, so I just keep it as 12 square root of 3. Bam! Number one is done. And again, if I get going too fast, just ask Mr. Piper. Or if you want to just watch, take a picture of my notes later, you can, okay? Number 2, I'm going to have 3 square roots of 6 times 2 square roots of 12. Okay, well, I'm going to multiply whole numbers with whole numbers. 6, square root numbers, square root numbers. Square root of 6 times 12 is 72. I know there's a perfect square inside of 72. 36 times 2. So we'll go 6 times the square root of 36, square root of 2. Well, that's no problem. Square root of 36 is a perfect square, which is 6. Oh, coincidence. 6 times 6 is 36 square roots of 2. Bam. Okay, again, if you want a copy of this when I get done, just ask Mr. Piper. Okay, number 3, or pause the video, that's fine with me. Number 3, 7x square roots of 50 x to the 9th. Well, 50 has a perfect square in it. 25 times 2. I want to take half of this exponent without getting a decimal, so I change it to the square root of x to the 8th. Oh, that's a bad looking 8. And square root of x. I know that 25 has a perfect square in it, which is 5. Take half of my exponent, x to the 4th, and then let's see what's hanging outside. So I've got 7 times 5 is 35 on the outside of the square root. X times an x to the 4th makes an x to the 5th. What's left inside the root is the 2 and the x. Boom. Okay, how am I doing? Okay, number 4. All right, you may have to do some work when I'm all done. I'm so sorry this did not copy. Maybe Mr. Pipe will have this copy to you if the copy machine's working tomorrow morning. Number 4, cube root of 216 x to the 12th y to the 6th. Now this is a cube root, and 216 is a perfect cube root because I think it's 6 times 6 times 6. So, and you have your notes on cube roots, right? So I think the cube root of 216 is 6. I'm going to take a third of my exponents because it's really an x to the 1/3 power. So I'll take a third of that, x4, a third of that, y squared, and I'm done. That's pretty simple. I like that one. All right, number 5. Let's see here. I'm going to have to fold my paper so you can see what I'm doing here. There we go. Just do that. Number 5, I have a 3 square roots of 18 minus a 4 square roots of 12 plus a 4 square roots of 50. Now I cannot add or subtract those until they're the same. So maybe if I reduce these, I might get that, okay? So let's see. 18 has a perfect square in it. 9 times 2. 4 has a perfect square in it. 4 times 3. With the 4, 50 has a perfect square. 25 times 2. Well, let's take the perfect squares of the square roots. Square root of 9 is 3. Square root of 4 is 2. Square root of 25 is 5. All right, so let's multiply the whole numbers. See what we get. 3 times 3 is 9 times the square root of 2. 4 times 2 is 8 times the square root of 3. 4 times 5 is 20 times the square root of 2. Now we can only add like square roots or like terms, and these, the 9 square roots of 2 and the 20 square roots of 2 are the same. I can combine those and have a 29 square roots of 2 minus 8 square roots of 3. Okay, awesome. All right, moving along. Number 6 is a 3 square roots of 5 times the 3 square roots of 5 minus a 5 square roots of 2. All right. I'm just going to distribute whole numbers multiplied to whole numbers, square root numbers squared multiplied by square root numbers. So I'll get a 3 times 3 is 9, 5 times 5 is 25, minus, oh yeah, 3 times 5 is 15, and the square root of 5 times square root of 2 is square root of 10. Okay, now let's see what I got. I have a perfect square, I like that. Okay, 9 times 5 is 45, minus 15 square roots of 10. I would like to subtract them, but I cannot because they're not like terms. I'm done. Boom. Okay. Moving on to 7. 7's a FOIL problem. Doesn't scare me. I can do this one. 7 is a 4 square roots of 3 minus 5 times 2 square roots of 3 plus 2. All right. Let's see what I can do here. I'm going to FOIL this. That times that, that times that, that times that, that times that. Or 4 square roots of 3 times 2 square roots of 3 makes 8 square roots of 9. 4 square roots of 3 times 2 is 8 square roots of 3. 5 times 2 square roots of 3 is negative 10 square roots of 3, and negative 5 times negative 2 is negative 10. Okay, let's see what I got here. Got a perfect square like that. That's 3. These two terms are the same, so I can combine them. 8 times 3 is 24. 8 minus 10 is minus 2 square roots of 3 minus 10. And finally, these two whole numbers can be subtracted. Give me a 14 minus 2 square roots of 3. All right, there you go. Hopefully I haven't made any mistakes. I'm sure if I have, you guys have caught them all by now, huh? Okay. Again, if I get going too fast, ask Mr. Piper to pause it or wait, watch, and take a picture of my notes, okay? Cube root of 125 over cube root of 8. Now it looks really hard, but it's not. Because the cube root of 25 is a perfect cube. It is 5. And the cube root of 8 is a perfect cube, 2. Boom. That was it. I like that one. But now number 9 is a little bit different. Sorry, Michael. Cube root of 27 over cube root of 5. Well, the cube root of 27 is a perfect cube root. That goes straight to 3 because 3 times 3 times 3 is 27. But 125, I'm sorry, I'll say it again. I'm ahead of myself. Cube root of 5 is not a perfect cube root, but I want to make it into a perfect cube root. So I can make it into 125. I want to make it 125 because that's a perfect cube root. So I'll multiply both the top and bottom by the cube root of 25, cube root of 25. I'm applying that rule of 1. You know, if you multiply by 1, you don't change the value. So let's see what I get. I'm going to get this 3 times the cube root of 25 over, well, the cube root of 125. Well, I'm almost done because don't divide those. That's not really 25. Cube root of 125 is 5. 3 times the cube root of 25 over 5. And that's it. Don't divide those. That's not really a 25. It's about, I guess, about 4.9 something or other. That's the answer you want. You've rationalized the denominator. I know, Michael. Sorry. And now it is in a better form. Okay. All right. All right. Number 10. The conjugate, huh? Don't you love the conjugate? So number 10. Again, we have to rationalize the denominator. So I'm going to go 4 over 2 minus the square root of 6. Okay. To rationalize the denominator, I multiply by the conjugate, only because there's a subtraction. If there's a subtraction or an addition, I multiply by what we call the conjugate. Opposite of that, right? 2 plus the square root of 6 over 2 plus the square root of 6. Has to be the opposite of that term, of that sign. So, let's see what we have. Multiply, multiply. It's kind of like your warm-up, right? 8 plus 4 square root of 6. And then if I FOIL this, I'll get 4, 2 times 2, plus 2 square roots of 6, 2 times the square root of 6, minus 2 square roots of 6, because that's a 2 times the negative square root of 6, minus the square root of 36, and because the square root of 6 times the square root of 6. And now what we've done is we really have eliminated our square roots from the denominator. These two terms cancel. The square root of 36 is a perfect square, which is 6. Let's see what I've got. I've got a 4 plus 2 square roots of 6 over 4 minus 6, which is negative 2, I can rewrite that as a negative 2 plus 1 square root of 6, because I can reduce that. I can reduce the whole numbers. Okay, number 11. Okay, 11 is really easy. You need to know this for calculus, that, number 11, sorry, that 16 to the 1/2 power is the same thing as the square root of 16, which is just 4. Boom, easy. Okay, that should be easy. You have to know that for calculus, which of course everybody's going to be taking calculus someday, right? Okay, 12. Let's see, there's a couple of things in 12. There's 3 things we got to deal with. 12, we have 32 to the negative 4/5. All right, let's see how I can tackle that. That is 1 over. Well, the 1 over comes from the negative exponent. 5th root from the 5, 5th root of 32 to the 4th power, okay? So fractional exponent, there's the power, and there's the root. Okay, 5th root of 32 is 2, because 2 times 2 times 2 times 2 times 2 is 2, so 1 over 2 to the 4th power, which is 2 times 2 times 2 to 2, which is 1/16. Bam! That wasn't so bad. You can do that one. 13. Okay, we kind of saw one like this on our warm-up. This is not too bad. Let's see what I have. Okay, let's see. I'm going to go and, first of all, apply the negative, but I've got 5 to the 8th over 10 to the 4th. You cannot make that 1/2 because that's 5 times. That's a whole lot of 5s. That's a whole lot of 10s. Now you could do it that way, except for this darn negative 1/4 makes it tricky. So the first thing I'll do is apply the negative, and I will reciprocate my fraction. Because this becomes negative, it comes up, that becomes negative, it comes down. So I'll rewrite this as 10 to the 4th over 5 to the 8th, and it's to the positive 1/4 power. Because all I did is took care of the negative exponent. Negative exponents will reciprocate my fraction. Now, I'll just take 1/4 of each of these fractions. I'll take 1/4 of these fractions. I'll get 10 to the 1 over 5 to the 2 power. Oh, this is getting easy now. Easy, 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 because a 10 to the 1 power is 10. 5 squared is 25, and that's 10 25s, or we can reduce. Why not reduce? Take out a 5, and I get 2/5. Even better answer. Even a better answer. Okay, let's take a look at 14. Hopefully you guys are following along. 14. Well, they're all cube roots. Cube root of 4, cube root of 32 over cube root of 2. It looks hard, but I think the first thing I might as well do is just divide this 2 into this 4. I mean, 4 divided by 2 is just 2, so I think I'm going to have a cube root of 2 times the cube root of 32. All I saw is I could divide. They're both cube roots. I mean, I may as well just divide them. Okay, so I did. Right? So now, that's the same thing as the, if I multiply them, the cube root of 64. That's 2 times 32. Oh, wait a minute. Isn't that a perfect cube root? Let's see. 4 times 4 times 4. I think that's a perfect cube root, which is plain old 4. All right. I'm moving along, and if you want a picture of my notes when we get done, you certainly can. Unless Mr. Piper's already got copies for you. We'll see, huh? All right. Let's take a look at the back side of this. Okay, so number 15. It says graph. Well, let me find some graph paper. Hold on. Got some graph paper hiding around here somewhere. And you can borrow graph paper too. So I know a couple of things about 15. The parent function of 15 looks like this. It's the square root, right? Y equals the square root of x. The square root of 0 is 0. Square root of 1 is 1. Square root of 4. Square root of 4 is 2. This is my parent function. 4 to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Square root of 9 is 3. Okay, so then and all the other square roots are in between. We also know that there is no graph behind here because the values of x have to be greater than or equal to 0. You can't have square roots in negative numbers. That's bad. We're not doing i's. So we know the domain is here. Now let's move this. A couple of things. First of all, we have a negative square root of x minus 3 over plus 1. So first of all, let's shift it. So we're going to move it to x minus 1. I'm going to take it to the we're going to take it its vertex or its endpoint to the right. 1. Remember, it's the opposite. And then up 3. So we're going to go, okay, to the right one. So we're going to go 1 and 1, 2, 3. I'm going to get a different colored pen. Why not? And then I'm going to take that and make it reflect. And so I'm going to take it and put my graph right like that. Now domain and range. Well, okay. Domain, it starts, the x value starts here at 1 and moves to the right, which means x has to be greater than or equal to 1. If it was less than 1, we'd be in trouble. And the range, it starts at a height of 3 and goes down, or the range is y is less than or equal to 3. Domain and range, and there's my graph. Okay, good. 16, let's look at 16. Okay. And again, if I get going too fast, ask Mr. Piper to pause this, or you're certainly welcome to copy or take pictures of my notes when we're done. 16. Let's see, g of x is equal to the cube root of x minus 2 plus 1. Well, let's take a look at the parent function again. I like the parent function is always a good place to start. Okay, my parent function looks like this. It's a cube root. Okay, cube root of 0 is 0. Cube root of 1 is 1. Cube root of 8. Cube root of 8. I don't need all the numbers in between. They're just decimals. Cube root of 8. 1, 2, 3, 4, 5, 6, 7, 8 is 2. Cube root of negative 1 is negative 1. Cube root of negative 8. Negative 8, right? Because all the others are just decimals. 1, 2, 3, 4, 5, 6, 7, 8. And cube root of 8 is negative 2. Okay, so here's my parent function, which we have in our notes. We have in our workbook too. We have both. Okay, now we're going to shift this. We're merely going to shift it to the right, 2, and up 1. So I'm going to take and move the inflection point. I'm going to move the inflection point because that's the easiest point to move. So move the inflection point 2 and up 1, which puts it here. And then I'm just going to do the same graph. 1, 1, 8, 1, 2, 3, 4, 5, 6, 7, 8, because the cube root of 8 is 2, negative 1, 1, and 1, 2, 3, 4, 5, 6, 7, 8. Cube root of negative 8 is negative 2. Okay, and then I just graph it in. Here's my parent function, and there's my translated function. Okay, so hopefully I'm not going too fast, but I know I'm going to run out of space on this video. Okay, so now domain. Well, domain's easy. I mean, all real numbers. You can put any number into a cube root, and we can look at the graph. It goes to infinity and negative infinity. So x equals all real numbers. And range, even though it looks like it's leveling off, it will always go up. And even though it looks like it's leveling off, it will always go down. The values of x are always going to, the values of y are always going to increase. The values of y are always going to increase. So the range is also y is equal to all real numbers. Okay. All right. There we go. I'm going to whisk this away. All right, 17. All right, we're going to solve. I like solving. You guys do too. Just have to be careful of some things, okay? All right, number 2. Let's see what I have. 17 is, that's what I meant to say, 2x to the 2/3 equals 8. Well, let's see. That is the same thing as 2 times the cube root of x squared equals 8. Okay, 2/3, same thing as cube root of x squared. All right, let's solve this. First of all, let's divide by 2. Divide by 2. I'll have the cube root of x squared equals 4. I will cube both sides to do the opposite operation of a cube root, and I'll cube this side. All right, so I'll have x squared equals, well, 4 cubed is 64. And then finally, I'll square root both sides, and I'll get x is equal to, well, plus or minus 8. Plus or minus, right, because it comes from an x squared. All right, 18. I've got the cube root of 8x minus 1 equals negative 5. Now, cube roots can equal negatives. If that was a square root, I'd be done. I'd say no more. Can't be negative, but cube roots can be negatives. We know that. Because negative times a negative times a negative is negative. All right, so let's solve this. I'm going to cube it to do the opposite operation of a cube root, and I'll cube this side. So I'll have 8x minus 1 equals negative 125. That's negative 5 times negative 5 times negative 5. All right, now I'll solve. Plus 1, 8x equals negative 124. Well, I think this is going to go unevenly. That's always nice. Divide by 8, divide by 8. 1, 8 goes into 12. Well, let me use my calculator, but I think it goes unevenly. Hold on. Negative 124 divided by 8, and I get an answer of, no, not exactly. X equals negative 15.5. Almost. Okay. Number 19. We're almost there. 19. Let me fold my paper. Again, you can pause if you need to, or just wait and take a picture of my notes. Square root 2x plus 1 equals 2 square root of x minus 6. So listen. The trick to this whole thing, to be careful of, is you're going to square both sides, but you have to square it. I'm going to highlight it. Listen, you have to square the 2, because it's outside the square root. You have to square it. So the square is the opposite operation of the square root, so I get a 2x plus 1 equals 2 squared is 4, and the square cancels the square root, x minus 6. Okay, don't forget to square the 2 is outside. Now, let's just solve for x. 2x plus 1 equals, I'll distribute, 4x minus 24. Okay, minus 2x, 1 is equal to 2x minus 24. Okay, plus 24, 25 is equal to 2x. Divide by 2, and I get, what's that, 12.5 probably. I can do that. All right. Almost done. I want to make sure this video gets done before we run out, okay? Number 20. Okay, this is when we have to be careful of negatives, because if we do the first part, 3x plus 3 is less than or equal to 6. If we just solve it, square it, we get 3x plus 3 is less than or equal to 36. Okay, I'm going to keep solving, okay? Keep solving. Minus 3, I've got a 3x is less than or equal to, what's that, 33. Divide by 3, x is less than or equal to 11. But we have to be careful, because that would include even negative 100. Well, you put negative 100 in here and you have troubles. That would include answers like negative 50. You put negative 50 in here, you can have troubles. You could put negative 1 in here, and that's about it. So if you take your 3x plus 3 and know it has to be greater than or equal to 0, because you can't have it negative because it's a square root, and you solve for it, you'll find what x has to be greater than. So minus 3, I got 3x is greater than or equal to negative 3. Divide by 3x has to be greater than or equal to negative 1. Okay, so here's the deal. The value of x has to be in between negative 1 and 33. All right? Hopefully I'll be here tomorrow so I can answer questions. We'll see, hopefully. All right? I'm going to whisk this way. Let's do the last problem, okay? So the problem with the last problem is we're probably going to have to factor. I think we've done this problem before. I think we did it yesterday. 4 square roots of x plus 1 equals x plus 1. All right, well, I'm going to square both sides, and I'm going to have to be careful. The 4 must be squared. The 4 must be squared. 16 times x plus 1, because the square cancels the square root. Now this is the same thing as x plus 1 times x plus 1, which if I FOIL it, x squared plus 1x plus another 1x makes it 2x plus 1 times 1. Okay, and you guys, you know how to FOIL. You do from here. Now this is a distribute. I get a 16x plus 16 equals an x squared plus 2x plus 1. We've seen this problem before. That's the good part. I can almost just get this done before the video ends. Minus 16, minus 16, minus 16x, minus 16x. Again, if I'm going too fast, ask Mr. Piper to pause it. I just want to get this done so I can go home. X squared minus 14x minus 15. That will factor, I like that. But we've done this problem before. X minus 15, x plus 1. So when I solve, I get x is equal to positive 15 and x is equal to negative 1. Normally I worry about negatives, but in this case, this one will work, okay? So, if you need copies of this, you need to go ahead and work on this for the rest of the period, please do. You can also work on your balloons. I will see you hopefully tomorrow.